Go ahead, Phil.
All right, so this is going to be talking about brokers in Helix, kind of their functionality, how to start them, and what they're used for. So just to kind of review some terminology for Helix, a federate is an individual thing that's executing. Core manages those federates, and brokers, which we're going to be talking about today, are coordinators for multiple cores or other brokers, and there can be several layers of these. In the top level, we call a root broker, and this we'll get into what it does in a little bit, but it's basically the master coordinator for starting a few things and a last chance router. And then, of course, the federation is all the federates executing together. The structure of Helix is hierarchical and layered, hence the name Helix. You have the federates at the bottom, you have cores in between that interact with the federates themselves, and then brokers. Brokers can manage one or more cores, they can be on multiple machines, and they can also be an intermediary layer where they communicate with higher layers or the root broker itself. And the root broker can be on the same machine as one of the other brokers or separate systems. So a broker has a couple responsibilities. Its main function once the federation is actually executing is to route data between different cores and federates. And so inside Helix there's a message structure that gets passed around, and all messages inside Helix are mapped onto the structure. The broker basically routes the data from wherever it receives it to wherever it's supposed to go. And this can be done in multiple different layers, so it can hop between layers and doesn't have to route to a higher layer but can route back down. It also functions as an intermediary timekeeper. Particularly this is true in messaging situations where you can have the possibility of sending messages from any federate to any other federate in the system. So in order to reduce the number of timing messages go out, the brokers can function as intermediary timekeepers. And this simplifies the timekeeping in the system and reduces the message traffic. The root broker itself also has a few other functions. It is responsible for initializing the entire federation. It does this when two conditions are reached. The first is that the minimum number of federates and brokers has been reached. So if you tell it to expect 3 federates, it won't actually start the federation until 3 federates are joined. More can join if more are joining, but at least that minimum number must be reached. And the other condition is that all the connected cores and brokers have indicated they are ready to initialize. So if a federate has not called the enter initialization mode function, the root broker cannot grant the initialization. When it is ready to do that, it also performs a number of checks on subscriptions and filters, make sure there's no name duplication, there's no all the subscriptions listed as required have been met with a matching publication. The same is true for filters. And during the execution, the broker functions as a last chance router because it knows where every federation is in the system or how to route traffic and data to it. The brokers work by creating 3 threads. This is not required, but this is how almost all of the main brokers you might use work. The only one that doesn't work this way is the test broker. But there's a main broker loop, and this broker is responsible for interpreting and using all of the data traffic that goes through it. It does the management, does the execution, and it's connected via 2 interprocess queues, or in-process queues. And these connect with a transmission thread and a receiver thread. And the purpose of these threads is to basically isolate the communication data from the data concerning the federation and keep everything in a container for thread safety. If you mix these two, you can end up with a lot of potential issues, and this is how we kind of separate out those concerns. And then there's an API layer that can actually communicate in a thread-safe fashion with some information in the main broker loop. To run a broker, there's slightly different calls in the C++ API and the C API, but you can create it through a broker factory. You specify a type, the name of the broker, and some command line arguments, or alternatively, you can specify those arguments as a string. And this will create a shared pointer to a broker for memory management. And after this, it's automatically connected and executing, so you don't really have to do anything with it unless you want to actually interact with it in some fashion. And then it will be destroyed when the object you store it in goes out of scope. In the C API, it's very similar. If you call the function HELICS create broker, this creates a broker of the specified type, along with the name and the initialization string or the command line arguments. The calls to this in the other language APIs are going to look pretty similar to this as well. The broker also functions as a standalone program. It's basically its own executable. On the command line, you give it a type, which is one of IPC, 0MQ, TCP, UDP, MPI, basically whatever communication medium you want the broker to use. It defaults to 0MQ, which is the default kind of mode for operation in HELICS. The name of the broker, this is used internally, and you can also reference the broker via other objects if they're in the same process. For command line arguments, the previous two were only available on the standalone executable. The other arguments I'm going to talk about work with the function calls. So there's a number of different arguments you can query using the $?or --help for all the potential arguments, but I'm going to just go over a couple of the main ones here. The --federates option specifies the minimum number of federates you want to connect to the broker. So this is the minimum number of federates you expect to have in the federation. Minimum brokers is similar. This is the number of intermediary brokers you expect to connect. The interface specifies the address of the broker itself. This is the address you're going to use in any give to any federate or core or sub-broker that needs to interact with this one. And this is kind of the communication path you use to connect with the broker. And you can specify this as a single string, in which case the port address and port number, or if you want to just specify the interface and local port separately, you can do that as well. And the broker address is the address of a higher level broker. So if this is an intermediary broker, you can specify a higher level address of the root broker or another layer. As far as the future goes, we have a few plans for enhancing brokers. One is to create a routing broker, and so this would be a broker that can support multiple interfaces. Say you had a situation where a chunk of the federation is running on a high-performance computing machine, and this interacts through the MPI layer, but then you need a gateway into a separate process that runs through ZMQ or one of the other protocols. And so the routing brokers would allow that capability. And also we're planning on developing a broker server. This is a server that can basically start brokers when you need it. So this would, if you have a situation where you're running a whole bunch of tests potentially simultaneously, you can start up the broker server and just have it automatically create brokers when one is needed. So this way you wouldn't have to restart the broker program manually for each simulation. And so this would be quite useful for smaller simulations or situations where you're doing a lot of tests. And I think that's all I have, and if there are any questions, I'll take them now.
Philip, I have a quick question. This is Karthik from ANL. So when you mention IPC, what exactly are you using? Are you using pipes or something like that, or how does the IPC work?
So that works using the boost interprocess queues. It does slightly different things on Windows and Linux. I believe it uses pipes on Linux, and it uses a memory map file on Windows. So it's a different mechanism. But
okay. Thank you. Another quick follow-up question. So, so the last slide you did mention like a broker server. So does that mean I can run multiple simulations of multiple core simulations concurrently, like what a web server does, like creates a thread or a new process for each one, and I can make it run for a bunch of Fed rates for case one and then a bunch of other Fed rates for case two.
That is the ideal. I mean, you're going to be limited by memory and port availability,
Mm-hmm.
but yes, that is the plan.
Okay. And would that be threaded or multi-processing for each broker?
Yeah, I would basically spawn a separate process for each broker, and then the addresses would be automatically assigned.
Okay. Okay.
All right. Well, thank you, Phil. Appreciate it.